So today we're going to take a look at the volt, which is the potential energy difference between two locations in an electric circuit. We're going to compare that first of all to another source of potential energy, gravity. So first of all we have the ground, and on the ground a stone. We're then going to lift the stone. Now we've lifted the stone against the force of gravity. So consequently, we've increased the potential energy in the stone. We can say that from a position of low potential energy on the ground, we've moved the stone to a position of high potential energy because we've had to move it against the force of gravity. This means we've had to do work on the stone to increase its potential energy. Work is measured in joules. A joule is 1 Newton metre. Of course, if we let the stone fall, it will naturally return to the ground. So, from a position of high potential energy to a position of low potential energy. This is a natural movement. Let's take a look at another scenario. This time we have a positive charge at location A and another positive charge at location B. And we know that between these charges is an electric field, which means the charges are repelled. There is a force pushing them apart. So, if we want to move the positive charge from location A to location B, we would have to do work on that charge against the force from the electric field. So we can say we have moved the positive charge from location A at low potential energy to location B against the electric field to a position of high potential energy. Let's now take a look inside a battery. A battery has a positive terminal and a negative terminal. And if we want to move positive charge from the negative terminal to the positive terminal, we have to do work on that charge. The energy for that work comes from the chemical energy stored in the battery. When work is done on the positive charge to move it from the negative terminal to the positive terminal, the potential energy of that charge increases. It moves from low potential energy at the negative terminal to high potential energy at the positive terminal. Let's take a look back at this positive charge that, if you remember, we moved against an electric field by doing work. We moved it from a low potential energy location to a high potential energy location. But what would happen if we stopped doing work? Just like the stone in our gravity example, the positive charge would move naturally from a position of high potential energy at location B to a position of low potential energy at location A. Now let's take a look at a real circuit. First we have a battery with a positive terminal and a negative terminal. The battery does work to move positive charge from the negative to the positive terminal, increasing the potential energy of that charge. But the charge has nowhere to go unless we build a circuit. Here we build a circuit with copper wire, a lamp, and more copper wire. The battery does work on the positive charge with low potential energy and moves it from the negative terminal to the positive terminal. This requires work. At the positive terminal, the charge is now at a high potential energy. Just like a stone falling naturally to the ground, the charge moves naturally through the lamp, losing energy, to a position of low potential energy at the negative terminal of the battery. Work now has to be done on that charge to move it to a location of high potential energy at the positive terminal. Notice also that the drift of the charge through the circuit is rather slow, about 1 metre per hour. Yes, you heard that correctly, 1 metre per hour. If there is a drop in potential energy, where has that energy gone? The answer is it's transformed mostly in the lamp to heat energy and light energy. Only a very small amount of energy is transformed in the copper wires. So let's review what we know. The battery, using chemical energy, does work on the low potential energy positive charge and moves the charge to a position of high potential energy at the positive terminal. It can then naturally move from a position of high potential energy through the circuit to a position of low potential energy. On the way, the potential energy is transformed into heat and light in the lamp. The potential energy difference between two locations is measured in volts using a voltmeter. For example, we may want to measure the potential energy difference across the battery. We would measure the potential energy difference between the negative terminal, one location, and the positive terminal, a second location. And we see that the potential difference is 1.5 volts. But what is a volt? We measure charge in coulombs, which equals about 6 times 10 to the 18 charges. When we apply a force of 1 Newton and move the coulomb of charge 1 metre, we have a potential difference of 1 volt. So, a volt is the same as doing 1 joule of work on 1 coulomb of charge.